All right, for example 3, part B, what we're looking at here is what about the limit as x approaches infinity of x squared over the square root of x cubed plus 1. So now, what's kind of the highest power in the denominator is going to be caused by the cube term, but it's sort of under a square root. So what we got to do is bring in the correct thing that will allow us to kind of cancel some stuff out. And there's a couple ways to do this. The way the book does it is they factor an x cube out and then pull that out front, and then kind of work on canceling that. So let's take a look at doing it that way so it kind of lines up with what's in the book. The other way is you can kind of bring in what you want here, like a 1 over the square root of 1 over x cubed, and you can kind of get yourself to the same place. But we'll try it the book's way. So the book says, hey, we can factor out an x cubed down here, and that will look like this. So when we remove the x cubed from itself, it leaves a 1. When we remove the x cubed from a 1, we get a 1 divided by x cubed. And now what we're going to do is we're going to kind of split stuff up. And we're going to try to bring in the correct thing to get rid of this x to the 3/2 power. Basically, it's the square root of x cubed. So the book brings in x to the negative 3/2, which I'm going to kind of write it as a 1 over square root of x cubed, all that over a 1 over square root of x cubed. And we can kind of see, if we do that, the 1 over square root of x cubed can cancel down here, and we get the limit as x approaches infinity. This would be x to the second power up top. This is 3/2 power down there. 3/2 power is 1.5. So you have 2 x's up top. You have 1.5 x's down here. 2 minus 1.5 is a single 0.5. So we have x to the 1/2 power as sort of left over up top. And then down below we have the square root of 1 plus 1 over x cubed. Now as x's head off towards infinity and get very, very big, stuff to infinity to the 1/2 power still trails off to infinity. So the top is approaching infinity. The bottom, as x's grow larger and larger and larger, 1 over x cubed is going to go smaller and smaller and smaller. So the 1 over x cubed part approaches 0. So we get the square root of 1 plus 0, which is basically the square root of 1. And so this is infinity over 1, which is infinity. And so the idea there is you kind of identify the x to the highest power first, and then we kind of factored it out and pushed it out front. We'd only do this with like roots, that if we're dealing with the roots of powers. And then we kind of bring in the thing to cancel it, and that kind of cleans up the issue.